Thanks again for joining the Phoenix LiDAR System April 2021 webinar. Today's topic is Advanced Imaging Systems, and we have two hosts from Phoenix today. We have head of our post-processing team, Conrad Quinterno, and we also have our VP of Sales, Justin Wyatt, and they have a couple of guests they'd like to bring up as well. So Conrad, let me go ahead and hand it to you to get started.
Thanks for joining us today. Like Lito said, my name is Conrad Quinterno. I'm the head of the post-processing division at Phoenix LiDAR, and I'll be walking through the first half of today's webinar.
Hi guys, my name is Justin Wyatt. I'm the VP of Sales for Phoenix LiDAR Systems. We also have Nick Anelio with us today, who's the Inspection Sales Manager for PhaseONE. Nick, you want to introduce yourself?
Yeah, Justin, I appreciate it. Hello, everybody. Good afternoon, good morning, good evening, wherever you may be joining us. Certainly grateful to be a part of this. When Justin and Conrad came to us about a month ago now to be, on this webinar series with such a high brand logo in the LiDAR world with Phoenix LiDAR, a superb reseller of ours. They do big things for us, not only in the unmanned space is primarily where I spend most of my time, but in the manned space as well. We've been doing some cool things. So glad to be a part of it and talk about some of the solutions we, do together to bring to the market today. Thanks again, Justin.
Absolutely. Guys, the format for today, we're going to try to split the time and kind of show the group the synergies between Phoenix LiDAR Systems advanced data collection tools and some of the advanced imaging systems that we use on our payloads, while really focusing on the partnership that we have with PhaseONE. In our opinion, PhaseONE makes some of the world's absolute best imaging systems. Our clients, I should say our joint clients that are merging our two systems together are really taking advantage of some of the best technology on the market today. So with that format, we'll get involved in this PowerPoint presentation and the webinar. And then following the information that you see on your screens, we'll open it up for questions and answers and leave some time at the end for that. So without further ado, I'm going to turn the time over to Conrad. Conrad, go ahead.
All right, thanks. So in the remote sensing industry, we're often dealing with pixels and points together. On their own, each of these are valuable, but together they really form a more complete view of whatever subject we're studying. Like Justin mentioned, today we're going to take the spotlight off of LiDAR on its own and change the focus and discuss advanced imaging systems. Yeah, so let's jump into it. The topics for today are going to be divided into Phoenix LiDAR Systems imaging options, then PhaseONE solutions, and Q&A like Justin just mentioned. Phoenix LiDAR specializes in building custom flexible mapping solutions. We integrate a variety of sensors into compact payloads that are really tailored to users' needs. In addition to building hardware, we also make custom software to support our users through the processes of data acquisition, post-processing, and final analysis. Our specialty is helping users get that maximum utility out of their remote sensing equipment. So why Phoenix LiDAR? We've been at this for a while now and are constantly striving to be the best. Although the UAV platform has been a significant driver of our innovations, we never limit ourselves or our users to a narrow view of how the technology can or should be used. Essentially, we want to build solutions for you. A major aspect to the custom breadth of our payloads is the camera selection. So today, let's take a look at why cameras are best considered as part of a payload overall, rather than just simply as independent sensors, and how that becomes an integral part of data quality. And also we'll look at some of the portfolio of the advanced image options that Phoenix offers. The advanced image options that Phoenix integrates are really part of a more complete solution. This is a situation where you might say that the whole is greater than the sum of its parts. That means that on their own, each of these sensors, like a LiDAR, GNSS antenna, a camera, or an IMU, however amazing of a technological accomplishment they may be, achieve more when they're working together. A couple of the most prominent benefits of an integrated payload are the ease of use. All sensors can be controlled by the same software and write data to the same location in a way that really benefits the user. It's also significantly less complicated to install a single payload than it would be to install all of these components individually. One of the cornerstone features of data that is collected by the scanners and cameras in a Phoenix system is that they're directly georeferenced for the position and orientation. This georeference comes from the GNSS-INS component. GNSS records position while the IMU keeps track of orientation. And when we couple these two pieces of information together, they form a highly accurate and precise trajectory. That trajectory is based on the IMU's reference point. So of course we need to use lever arm translations and foresight rotations to extract the pose of each sensor during the entire flight. This may be a familiar concept to some of you, but I'm really bringing it up because of the major benefit that direct georeferencing has when you're collecting data from a LiDAR and a camera at the same time. With the multi-sensor payload using a single trajectory, we enable a virtually automatic co-registration of LiDAR cloud and imagery. The sensors share a similar view of targets as they're moving along their flight path. And because of this, we're able to get really crisp RGB colorization in the point cloud, minimizing the amount of occluded areas and shadowed areas. If you were using separate flights to collect LiDAR and imagery, then the perspective you capture in the image data might not fully cover what you see with the LiDAR, so like walls of buildings and things like that. So the single trajectory really helps that synchronization of data content. It's also really important if you're building ortho photos from imagery. After a bundle adjustment and mosaicing, your ortho will still horizontally align with your point cloud. It's not necessary to extract tie points from the LiDAR in order to modify your finalized ortho. It should be properly positioned, right from the get-go, and that's because it's been directly georeferenced. The first unique camera in our portfolio is the custom A6K Light. This is the RGB workhorse that excels at UAV-based mapping. The camera is miniaturized and very lightweight for extended flight times. It uses an APS-C CMOS sensor that collects 24 megapixel imagery. Typically, we use a 16mm lens, which gives roughly a 70-degree field of view, which increases the user's ability to space out flight lines and collect larger areas. This camera is purpose-built by Phoenix LiDAR Systems and designed for ease of use. One of the great benefits, especially from a post-processing and data management perspective, is that images are written directly to the same solid-state storage location as the LiDAR and navigation data. So your entire project is in one place, which really enables that seamless post-processing. The next advanced imaging solution is the dual-oblique configuration of that same A6K Light camera that I just discussed. Sometimes the nadir straight-down perspective is not good enough to get RGB texture on vertical objects, and that is where the oblique view really becomes valuable. For this configuration, we mount two opposing cameras in low oblique orientations. The resulting coverage is about a 140-degree field of view. That wide FOV allows users to colorize LiDAR from a single pass when high scan angle data is utilized. You can see from the screenshot that nearly all of the point cloud data that was collected from a single UAV flight line was able to be colorized from oblique imagery from that same flight line. So you can get, almost entire RGB coverage without relying on overlapping passes. Another variant of the custom camera platform is our multispectral solution. In this option, we utilize two downward-facing cameras. One of the cameras collects the standard red, green, and blue bands, while the other is an infrared-capable sensor that uses a bandpass filter to acquire data from the near-visible infrared spectrum, so roughly like 700 to 1,000 nanometers. In this rather lightweight UAV payload, we can collect the spectral information to colorize LAS 1.4 red, green, blue, and N channels. So you can get that 4-band data into the point cloud. That can open up a new world of possibilities for data analysis, like, for example, determining NDVI directly in a point cloud. This camera setup gives us the data we need to make 4-band orthos as well, and move into many different methods of raster analysis. Adding that near-infrared channel gives us valuable information that our eyes just can't see, and we can use this information to perform vegetation analysis, land cover classification, and other types of spectral studies. Then we can go even further into the infrared with our thermal mapping camera. Collecting the thermal wavelength results in imagery that can be converted directly to degrees Celsius. The digital values collected can also, just like with any other integrated camera on one of our systems, be written to a LAS file. This imagery is also useful for making thermal maps, so like 2D orthos. And a key feature that enables the creation of high quality thermal maps that are free of temperature drift throughout the flight is the external calibration shutter. So periodically this sensor recalibrates so that data from overlapping passes is consistent and accurate in the temperature reading. Target emissivity is definitely a major consideration when analyzing thermal imagery, but by using thermal data loggers, we've seen that this scanner actually can live up to its 1.5 degree measurement accuracy specification. We've most often seen this thermal sensor employed for environmental monitoring and infrastructure inspection. But there's many other applications for thermal imagery that you guys probably all have in mind. We also integrate hyperspectral sensors into our payload. Hyperspectral sensors operate in approximately the same region of the electromagnetic spectrum as a 4-band multispectral solution, except instead of collecting 4 broadbands, it collects hundreds of narrow slivers. These narrow band measurements form a spectral signature of each type of object that they collect data from. It is a passive scanner like other cameras, but instead of collecting large frames of imagery, it collects in what's called a push broom style. And that's essentially a single 640 pixel wide line of data per exposure. This results in kind of a long stream of data, commonly called a data cube, which can still be produced to yield 2D imagery, like what you would expect from other cameras. The applications for hyperspectral are really wide, but most commonly we see users performing things like precision agriculture and other vegetation or land cover type analysis. The final camera option that I'll quickly discuss before handing the presentation over to Nick, are the PhaseONE mapping cameras that we have integrated. These are the highest resolution and highest quality cameras available. They can be used from a UAV in a mapping configuration to create amazing data. And we've also seen them really stand out from the airborne or helicopter scale collection. One of the key benefits is the medium format sensor size. This is a major differentiator between cameras in terms of resolving power. Another extremely useful aspect of their imagery is that we can develop them directly to undistorted frames by using a factory camera calibration, which makes the photogrammetry process quite a lot simpler. The screenshot on this slide is from a 4-band mapping mission that we performed. One of the coolest aspects of this data is how well the aquatic vegetation pops out in the color infrared, especially compared to the visible imagery. You can see a major contrast in this false color composite between the blue water and the red vegetation, where if you're just looking at the red, green, blue image, it's all really kind of green looking and harder to differentiate. If you'd like to check that out, definitely visit our website and look up the sample page, or you can type in this URL quickly. Go ahead and give that a shot. So thank you all for your attention, and now let's pass the mic over to Nick.
Yeah, Conrad, I appreciate that. I am going to share the screen with everybody. Alrighty. All right. Again, hello, everybody. My name is Nick O'Neilio. I am the inspection sales manager here at PhaseONE. I've been here about 1.5 years now. Joining me on the call, and he will be popping in the Q&A section with me, is my colleague and partner who handles all of our system sales. So like I said earlier, I mainly deal with the unmanned space, but I've eventually evolved, like we have with our partnership over at Phoenix LiDAR. We've evolved our offering not only from the unmanned space with drones, we have dabbled into manned space, specifically with our 4-band kit. This has been a big hit with Phoenix LiDAR and their offering to their end users. So I'm going to specifically talk about that. Again, we want to thank Phoenix LiDAR for giving us the opportunity to sit in. Yes, be a partner of yours for almost 5 years now, I believe. But yeah, again, my name is Nick. Joining me later in the show will be my colleague, Kevin. A little bit of introduction here with PhaseONE. So diving into it. So PhaseONE, we are a global digital imaging pioneer. And so we are a camera manufacturer, long story short. Been around now for almost 20 plus years. Have offices all over the world, from Japan to Germany, here in the US, headquartered in Copenhagen, out of Denmark. As you can see here, we have R&D centers in Denmark, Israel, and Japan. Most of this you could call our testing our new products, where our manufacturing, where we'll get products from, come from those areas of the world that get sent over here to the US. We are, our lenses get made in Japan. Over 1/3 of our employees are in R&D in these parts of the world for us. We have, call it, sales and marketing and support offices here in US and in Germany for the EMEA division, with our in-house manufacturing in Japan. Our systems are calibrated. We are, a couple of our advantages here at PhaseONE. We are a medium format, which Conrad hit on. So we are 2.5 times larger than your standard off-the-shelf DSLR camera. So you're going to see 2.5 times more in a single image. And then secondly, we're a medium format metric camera, and those systems come metric calibrated from our Israel R&D center. Let's see here. Some of our top customers, of course, you'll see there. 3 out of the big 5 tech giants we currently serve today. You could probably, everyone attending today would have a good idea of those 3. We have leading global organizations and institutions within different applications. Here we highlight environmental and cultural. And then we have current partnerships and joint innovation, of course, with Sony, Snyder Kuzbach, Rodenstock, and then a big GNSS IMU partner of ours, Aplanix. We do have SDKs available. I know those out there today. Most of our integrators have their own SDKs, but we do have those options available for easy integration in any post-processing software out there that you use today. So diving in to our aerial systems today, is our 4-band imagery. So basically going into this, I'm going to get into our 4-band solution, as you can see here today. So with the increasing demand and combined with that near infrared and the red, green, blue RGB aerial imagery for applications, not only from crop analysis, veg health, and environmental contamination, Phoenix LiDAR has brought a wealth of opportunities, whether that's corridor inspection, any type of application out there needing this, as well as products including city observation for green site monitoring. We have developed here at PhaseONE a fully, we could like to say, automatic solution for capturing and processing this 4-band multispectral imagery. The 4-band system solution is specifically designed for photogrammetric airborne market. We use 2 high-resolution PhaseONE aerial cameras in that. Basically, the 4-band solution includes, we want you to know that this is simplifying your workflow, and this includes 2 PhaseONE metric calibrated cameras, the RGB and the achromatic. Those are mounted side by side, which you see here in my presentation right now. We basically, some of the output products could be anything from a 4-band near infrared and RGB TIFF to a 3-band combined near infrared with an RGB TIFF. Of course, the NDVI TIFF, and then of course the distortion-free corrected RGB TIFF, and then the RGB and near infrared TIFFs. Basically, this is a one solution. We like to say a one solution for all. And by that, I mean, this is the perfect choice for a 4-band precise requirement. It's a cost-effective solution compared to those competitors we have today that we go up against. I like to say this is flexible. There are 2 cameras that can be used in different combinations together or standalone for, very simultaneous projects that you may have today. Of course, we like to say we're lightweight and compact. We're easy to install in small aerial systems, small aerial platforms. We have a simple workflow that we reduce hours spent post-processing, and we have a reliable output. And what does that mean? That is going to give you accurate, high-resolution imagery. Let's see here. My screen kind of funked up on me. But basically here, some kind of specs of this 4-band system today. Along with our 4-band system today is we call it our Ix controller. And now we have the Ix controller, our Mach 5. And what that is, as I go to my next slide, our Mach 5 controller with what you see here sets on top of this. This is a SOMAG mount. I think that's a DSM 400. It is setting on, but our latest PhaseONE Ix controller is going to be a robust command center, call it for basically a control hub that is designed for smooth geospatial missions. With this precise and precision of the GNSS internal unit now integrated, so the difference, some of those out there today are going to be asking, what's the difference between the Mach 4 and the Mach 5? Again, it is the GNSS inertial unit now integrated inside our Ix controller. The setup of our PhaseONE aerial system solution is simpler. This supports a wide range of our orientation accuracies. And of course, it's going to save installation time down the road. This is specifically designed, our Ix Mach 5 is specifically designed to address the challenges of image data acquisition, helping give you, the operator and pilot, improved productivity and saving you time and money. This controller comes with custom cables that we supply you with, ample support to connect up to 6 cameras, 3 monitors within the aircraft, a gyro stabilizer, and that Aplanix IMU unit and the standard aircraft power supply. This high capacity data storage, our SSD trays, can be easily accessed for removal or rapid download of image and telemetry data. Some of the things, again, to highlight there, again, it controls up to 6 cameras and that gyro stabilized mount. Of course, the rapid data transfer. We have a high capacity storage again with our removable dual proactive SSD trays for SSD storage. And again, that internal integration of the GNSS and inertial unit, enabling a simple setup of aerial solutions. This does connect, again, directly with that Applanix IMU series with multiple upgrade options to higher accuracy models. As we go on here within this application here, again, a wide range we're seeing from our aerial customers today that I know Kevin can elaborate more on in the Q&A section. But again, we combine our technology with expert knowledge across many geospatial applications, from, of course, the mapping and surveying. We're getting into 3D mapping and oblique imagery. And then with a release later this year, it's a big one for us, our PAS 880 megapixel solution, widely known for that citywide smart city mapping. And again, the main purpose of this presentation today within our ag and environmental productivity application. And then on the right there, you'll get into the critical infrastructure with inspection with our IXM camera. As I lead in, that leads into my next slide. Again, our IXM camera gets into the UAV application space, which Phoenix LiDAR, to highlight, is a reseller of our IXM application. Like I said earlier, our partnership has evolved into what Grayson and company started out as reselling our IXM for unmanned aircraft and unmanned applications, now into this manned arena for the multiple camera array option, whether that's for inspection or mapping applications today within manned aircraft, whether that's an aircraft, an airplane, a Cessna, all the way to a helicopter. As you can see here down below, our IXM-RS series goes from everything to your manned aircraft, which then you see here the 880, which is our new aerial mapping system today. And then again, the multiple camera arrays, which primarily highlights this 4-band system that we offer in conjunction with Phoenix LiDAR. And what's great, I should highlight too, from the Phoenix side is, the partnership we have, folks, whether they come to me directly or go to Phoenix directly, we are the same price across the board. What you get with us is what you're going to get with them. So you're going to get it the most competitive price point out there. And then from the support side, I think Conrad, Justin, even Ben Adler can attest to this. I think myself, Kevin, and even Lewis at times, a support side from the PhaseONE we work very well in conjunction with Phoenix to get that answered as quickly as possible, whether that's an issue in the field, whether that's hardware, software. We're going to be able to support and maintain that product to hopefully get that lifelong longevity out of the customer and help equip each aircraft that you bring aboard as you grow your business out there today. And finally, a big highlight for me in going on to Phoenix offering is our PhaseONE P3 Payload. And what this basically is our new product offering in the unmanned space, specifically for inspection applications. And if you see here, there's some key main parts that we're looking. So at the guts, this is a Grimsey gimbal, what you're looking at right now. But it's a mixture of parts and pieces from a T3 and a T7, specifically customly designed, that we worked with Grimsey on to hold our IXM camera, 3 different lens options from the IXM35 all the way up to the 150. But our big piece that we've added is this basically smart tool we call our laser rangefinder for that accurate distance from the structure to get that area in focus, whatever it may be, from a cell tower to a wind turbine, bridge inspection, even T&D in the utility space. But this is going to be aboard the DJI line, the M300 specifically, and then the P3 for Mavlink. So those Mavlink-based systems out there today, there's a handful of UAS manufacturers we're working on today. But as I end, before I pass over to Conrad again, my name is Nick. Joining me in the Q&A is going to be my colleague, Kevin, who runs our system sales, and we look forward to those questions out there today and getting them answered. Over to you, Conrad. Thank you again.
Thanks, Dick. That was great. I think now let's open up to some question and answer with the audience.
All right, looks like we only have one question here so far. Hopefully we can get a couple more in. What I have here is, let's see, let me just read it off. As opposed to using a single camera, does the use of a dual camera add an extra layer of georeferencing accuracy when viewing the same target from both cameras with an overlapping region?
Yeah, I guess.
Go ahead.
Yeah, I can take that. For us, yes, just because you're getting that, not only, you know, the RGB side of that, but the achromatic side for us, it's kind of that kind of dual frequency of stable accuracy confirmation with our 2 metric calibrated cameras coming directly within this offering on the dual side from PhaseONE side.
Yeah, and as far as the accuracy of each camera, when we're integrating multiple, they sort of get calibrated on their own. So like the RGB camera calibrates using observations from overlapping images from other pictures from that RGB camera. And then the infrared would use observations from overlapping images from that same camera. So in terms of the initial calibration, it doesn't necessarily increase accuracy of that.
I think it can actually be a great tool to double check or to verify, especially heading accuracy, which tends to be one of the hardest to pin down. So the wider your camera field of view is, the more you're going to see mismatches in colorization. We also do usually calibrate cameras against themselves, but we also have algorithms to calibrate camera against point cloud. So we can use the properties of the points in the point cloud to make sure LiDAR agrees with cameras. And there are some cameras and some camera mounts or ways of mounting cameras that make this useful.
So Conrad, from a point of view, from the post-processing point of view, what are the, I guess, the major differences in doing post-processing with an APS-C camera versus a medium format? Obviously, I mean, I think I can imagine that the sheer amount of data would be maybe a challenge. What are your thoughts on that?
Yeah, I mean, I think really for a lot of the people out there in the orthophoto world, they understand that like size of a pixel is hugely important. You know, that's what really gives the camera like the resolving power that it has. And so, you know, if you're looking at larger pixels, they're going to be crisper and have a better signal to noise ratio essentially. So that's I think the key differentiator in terms of like the quality of the radiometry of each pixel. In terms of post-processing, yeah, the file size is a consideration, but even with these 150 megapixel cameras, it's not too overwhelming because, you know, you're not really like crawling through each image by hand. It's kind of just a data storage and data management minor issue, I would say. But the metric aspect to the medium format cameras from PhaseONE is really a nice thing for post-processing, because we can get the imagery undistorted really kind of right before we do anything else. That makes it so that we're solving less variables when we're trying to calibrate our foresight values and also calibrate our data sets.
Thanks, Conrad. And I have another question, actually either for Conrad or from the PhaseONE team. And I know you briefly touched upon this in your presentation, Nick, but what are the sweet spot applications for the hyperspectral imaging offerings that you have and that we have?
Yeah, I'll go first. I guess for us, as far as a sweet spot, I mean, that could vary on the type of application and criteria needed. I know, for example, like a field of view to align with a Phoenix LiDAR product, we give that field of view not only from the across flight in degrees, but from the along flight. And then our focal lengths, I mean, we go anywhere from 32. We even have a 23 and 28 millimeter. But with this specific offering, we offer 32 millimeter all the way up to 180. And those degrees are going to give you anywhere from 70 degrees. I think it's 77.8 is our across on the 32, where on the along with our 32 millimeter is going to give you 62 degrees. But that is a key part. And I think another thing before I hand it over to you, Conrad, is our the aperture and our dynamic range feature within this. Just being able to lighten those darkened areas. That's a key advantage for us. I know that we usually tell folks when selling the product. Kevin, I don't know if you have anything to add onto that, but that's kind of my 2 cents if you have anything else to add.
Nope, sounds good.
Yeah, and then from our side of things, the hyperspectral imagery that we're getting is that like 640 by 1 pixel frames. So it's this push frame style data acquisition, and really the sweet spot applications for that are things where you're trying to find these subtle but consistent differences between objects with how they interact with the electromagnetic spectrum, ranging from visible to infrared. So like slightly different pigmentation, slightly different cell structure that's interacting with the light that's reflecting off of it. So that would include most things vegetation, like differentiating types of plants, types of trees, differentiating the health of plants and trees. I think really that near infrared interaction with plants is based on their cell structure, not necessarily just like the chlorophyll. So a plant could look like green, while another one, isn't green because of chlorophyll, but that doesn't really necessarily mean that their cell structure is, more healthy. So that's kind of what the infrared does, is it gives you this ability to perceive something about the object you're looking at that you can't just tell by, looking at the color of it.
Great, thanks, Conrad. Thanks, Nick, and thank you, Kevin. Justin, from the sales point of view, from the sales side, what do you use to determine or to determine with the customers what the best imaging system is going to be for their needs to go on to match with their LiDAR system that they're interested in purchasing?
It's a great question, Lito. It really depends on, well, first and foremost, when you give us a call and you give PhaseONE a call, the first thing that we're going to do is we're just going to take down some basic information from you. If you have experience in the orthographic world and are just dipping your toe in LiDAR, or if you are brand new to both, we'll work together with ourselves in PhaseONE to find a better time where we can jump back on with you and your stakeholders to really pinpoint the solution. But from that first call, we're just going to take some basic information. I like to work with people personally who are brand new to this because what we're going to do is we're going to go to give you a very high level overview about how the solutions can work for your particular applications. And then based on your budget and kind of your expectations on when you want to roll this out, we'll work with you hand in hand to find out solutions that work for your team. A lot of this can be very scary when you've never done it before. I promise you that through the training programs that we have implemented, we'll work with you hand in hand for any level of understanding and experience to make sure that you have a program in place to launch the technology and get the ROIs that you're seeking. So from the sales side, really it's about discovery, understanding what's most important to you from the solution. And as you've seen from the presentation, there are a ton of different options out there. Obviously, they're based on capability, accuracy, weight, dimensions, price, and we'll work with you to make sure that you can get all the answers that you're looking for with no pressure, and make sure that you can understand what it's going to take to make it successful.
Justin, if you don't mind if I add, I think you made a point to me when you first came aboard at Phoenix LiDAR, which I think is, I don't know, I've kind of taken it with me here at PhaseONE, but when we work together, I remember Justin telling me, we're working not to sell products, but to solve problems. And so that's where we help qualify one another. May it always be a PhaseONE camera? No, we know that. But when that time is right and that problem is needed with our gap fillers that we can have in our product, then that's where we can join together.
Absolutely. Well, if there's no more questions, Lito, it looks like maybe someone popped into the Q&A. If you want to tackle.
Yeah, there was another question that popped up. Yeah, does Phoenix have a government VAR program or a government contract in place? Sorry, government program.
Yeah, so I'd like to probably curb that. I can give you some high-level information. We do have a value-added reseller program. If you are interested in being a part of that program or would like to be a part of our distribution channel, please send me a direct message either over LinkedIn or at my email, which I will have go out when this webinar is distributed. We also do sell to the government, and we give specific discounts to the government because they have the ability to work on special projects and offer tax write-offs and that sort of thing. But all of those details can probably be best answered on a one-on-one once we've put an NDA in place and can get deeper into our resellers program.
Okay, great. All right. Let's see. Conrad, I'll open this up to Conrad, Justin, Ben. Anybody have anything to add regarding our Phoenix Advanced Imaging System offerings? I think Justin actually gave, and Justin and Nick gave a pretty good close already, a good summary. Basically, we're here to help you solve your problems. We will help you come up with a solution, and that's what we're here to do at Phoenix LiDAR Systems. So on that note, thank you very much, everyone. We appreciate you joining our April 2021 webinar. We will have the topic of the next webinar really announced shortly. Look for us on our social medias at Instagram, Twitter, Facebook, YouTube, and LinkedIn, the usual channels. And thank you very much. And everyone, take care. Stay safe out there.